Okay, so today we're going to talk about proportional reasoning. Proportional reasoning is a really useful skill, and once again, that's going to be shown all throughout AP Physics 1. That's why I'm including this in like my Unit 0 videos. It just shows up everywhere. And proportional reasoning is pretty cool because the whole point of proportional reasoning kind of asks, what happens when you change this? So if I'm throwing a marker up in the air, what happens to the max height when I make the upward speed twice as great? What happens to the time in the air when gravity is half the strength or whatever, right? It's all about asking what happens to this or what happens to that when this happens or when this changes. So I'm going to get a little problem up here and we can work through it. All right, so I just have a little bit of a problem here. I just kind of came up with on the spot. So basically, a car is driving at a certain constant speed and then slams on his brakes. He experiences a certain acceleration and skids a certain difference before stopping. So basically what's going on, this car is driving, I don't know, whatever speed, and then he's gonna slam on his brakes. Now, and you'll learn this in forces, he's gonna have an acceleration. Now, his acceleration is gonna be the opposite direction. And this is a kinematics problem. So if you haven't, gotten here this far, I would recommend, waiting a few weeks to learn about this stuff. You can come back to this video. He's slamming on his brakes and he's gonna feel like an acceleration. He's gonna, decelerate, right? He's gonna experience this acceleration in the other direction. That's gonna slow him down. He's gonna slow down and he's gonna skid a certain distance before stopping. So the question asks, well, what happens to this distance, like that stopping distance, let me just pick up my marker, if you were driving twice as fast, but just had that same acceleration? So here's how you would approach this proportional reasoning problem. I know it's a proportional reasoning problem because it's asking, hey, what happens to the distance if you were to change the speed, right? What happens to the distance if you were moving twice as fast? So let's talk about it. Now, the way you would kind of approach this problem is first, you got to think of a physics equation. What physics equation is going to help you out in a problem like this? We're dealing with speed, acceleration, so initial velocity, right? So initial velocity, acceleration, distance, and this is kind of like, a kinematics problem. I won't go too much into it, but you're also dealing with the final velocity. It's going to be 0 when you're stopped, right? So a physics equation I think of is v final squared is going to equal v initial squared plus 2 times the acceleration times the displacement. So now I just plug in plug in the variables of what I know. V final is going to be 0. Okay. V initial is just v initial squared plus 2 times acceleration times change in x. So now what I'm going to get is I can kind of rearrange things. So I get negative v naught squared is going to equal 2 times acceleration times change in x. What would actually end up happening is your acceleration is going to be negative because it's going the opposite direction, and your velocity is positive, so it's just positive. So this negative, if you were to plug in the numbers, the negative would cancel out. I'm just going to get rid of the negative because it's not going to make too much of a difference whether you leave it in or not. But here's how you would do proportional reasoning. So I want to see, well, what happens to the skidding distance, okay? So the way that teachers teach it at the high school I go to, I'm not going to say because I think there are other people who don't know about, they're just random people who watch. So I'm not going to leak that out. But what I think the way that teachers teach it at this school is they kind of say, okay, we want to figure out what happens to this, right? What factor does it change in x change? Does it become twice as long? Does it become half as long? Does it become 4 times as long? 8 times as long? Whatever. I'm trying to figure out what that factor is. I know my acceleration is going to stay the same. And this 2 is also going to stay the same. So it's 1 times question mark. And then what you would do is you would say, okay, the V naught is going to get twice as big, but you're going to square that. So what's happening is that you have V naught squared equals 2 times acceleration times change in x. So this change in x, this blank, represents like, is it going to be 2? Like, is it going to be 2 times? Is it going to be 4 times as much now that you've changed it? So really, this would actually look like this, right? So when you make the velocity 2 times bigger, well, you're squaring that, right? You're not doing 2 v naught squared. You're doing 2 times v naught squared, right? So that squared is going to get distributed to both, and you end up with 4 v naught squared. And in order to make everything equal, if I multiply this side by 4, I have to multiply this side by 4, and that ends up being 4 times the distance. And the way that they show it here is that change in x, trying to figure out how much it changed. Acceleration stayed the same, so it's a factor of 1. 2 stays the same, it's the same number. And then this v naught changes by 2, but then you also got to square the v naught. So it's really 2 squared. You get 4 is equal to 1 times question marks. So if, well, these ones don't make a difference, right? Multiply anything by 1, doesn't make a difference. You get question mark is equal to 4, or it changes by 4. So that is kind of how you can do proportional reasoning. Here's another strategy too that I actually prefer, but you know, it's just more, to me, it makes more mathematical sense. One thing you could do is you can like kind of derive an equation. You could kind of say, oh, well, let's get that back. You could kind of say, okay, well, if I solve for change in x, I divide everything by 2a. So I get v naught squared over 2a equals change in x. So I can call this the change in x, the original like first time change in x, right? This is the change in x that happened the first time around. But then when he goes twice as fast, I can use that same equation and be like, well, if I take that equation here, I could say like, okay, well now I get 2 v naught squared over 2 acceleration is going to equal the change in x, and I'm going to call this the change in x new, right? The new change in x, right? The new skidding distance. So I would basically take the square, right? I get 4 v naught squared over 2a equals change in x new. And then one mathematical strategy I can use is I can kind of rearrange this so it looks like this. Oops, sorry. Just writing in the variable here. So 4 times v naught squared over 2a. I can just take the 4 out of the fraction. But what's v naught squared over 2a? Well, v naught squared over 2a is the original change in x. I can substitute that back in, and I get 4 times change in x original equals change in x new. So I basically get the new skidding distance is 4 times the original. It gets 4 times bigger. That's another strategy you can use. You can choose whatever one works for you. It's up to you. That's how you would do proportional reasoning. Thank you for watching, and hopefully AP Physics isn't going to be too bad this year.